Welcome to Group 4's tender submission for the Calamount Residential Subdivision in Vaughan, Ontario. Please note that this video is made for academic purposes only. We will begin with our approach to the layout of the construction site. All traffic will enter the site from Gate A, which is located at the red arrow. From the gate, a temporary road will be installed to the park, which will become our mobilization area. This area is outlined in red on the drawing. We have chosen this as our mobilization area because it provides sufficient space and is close to the entrance, which will minimize the distance traveled by equipment. The green arrows on the drawing represent the sequence in which the lots will be graded. This route limits the distance traveled by equipment, therefore lowering costs and ensuring no repetition. The lots closest to the mobilization will be completed last to minimize the disturbances to the final grade caused by frequent equipment movement in this area. The blue areas on the site layout show the path traveled by concrete and asphalt crews to maximize efficiency by using the cul-de-sac as a means to safely turn machinery and trucks around while exiting the worksite.
The first step in the earthwork calculations was determining quantities of soil. This was done by using the provided AutoCAD drawings to measure average grades and areas for each of the three project parts, which are the lots, cul-de-sac, and blocks 169, 170, and 171. By comparing the amount of cut and fill, we were able to determine the amount of borrow and the amount of haul required in each of the areas. The next step for earthworks was determining the productivities of all the equipment that was used. This includes a scraper, dozers, transport trucks for bringing material in for fill, transport trucks for taking out contaminated soil, and loaders for loading those trucks. The third step in the process was determining a schedule. What you see here is a first attempt, and below is the schedule you'll find in our submission. This attempted to level out the amount of trucks required to bring in material each day. And of course this created a spoil bank, which was maximized on day 4 here, and its size is calculated here. And the last step for earthworks was determining the costs of all of these parts. This includes fixed costs, fuel costs, operator costs, depreciation costs, and others. And those costs are summarized here, and you can find the same table in Appendix C.
Hello, this is Andrew Mancini. I'm just going to be going over the concrete construction methodology for the curbs and sidewalks. So the option 1 cost was $185 per meter cubed. We were told that we needed 700 meter cubed total. So that was an easy final price to get of about $130,000 right here. Now for option 2, we needed to use Condrain's batching plant. So we still needed 700 meter cubed regardless. And the first thing we did was calculated the material costs here based on the proportion of gravel, sand, cement, and then we factored in labor and the operating costs of their batching plant as well, which we're going to use for 2 days. So that total comes out to about $70,000, as you can see here, but we still have to factor in the truck costs and the delivery costs. So what we decided to do was use 2 ready-mix trucks to deliver the concrete from the batching plant to the job site. And so the cycle time per truck is about 20.1 minutes. You can find that in Appendix D, how we got that. And so what we're going to do is pour 350 meter cubed on day 1 and 350 meter cubed on day 2. Basically split it up between 2 days. So each truck is going to be doing, so we need 35 cycles per day total, but there's 2 trucks. So each truck's going to do about, let's say, 18 cycles a day. And then below here we have the rest of the costs that we need for the trucks, so the fuel costs, service costs, tire costs, all of them are here, and you can find how we got those in Appendix D. So finally, once we add these costs here to the 70,000, we get a total cost for option 2 of about 85,000. That's quite a bit less than option 1, and so we're going to go with option 2 for concrete, using the Condrain services and batching plant. Thanks.
After concrete operations completed, asphalt could begin. The team multiplied the plan areas of the road by the corresponding thicknesses to obtain a volumes quantity. Option 1 produced a total cost of roughly $35,000 given the total quantity of asphalt needed was 205 meters cubed. Option 2, however, utilized Condrain's existing plans, therefore material and delivery costs needed to be calculated. Once we found the cycle time of our internal company truck in order to reach the batch plant, we found out we would need 2 days of operation with the truck. One lift would be completed on day 1 since the asphalt paver can only complete a 5 cm lift per day. The following HL3 lift would have to be placed the following day. Given the total time of the transport truck in operation, 5.68 hours, we were able to find all appropriate costs for option 2. This roughly equaled $25,000, much cheaper than option 1, therefore it was selected. Once we added in the cost of our asphalt paver, we obtained a final cost of roughly $28,000 for all asphalt operations. Crusher run limestone also was needed to provide a strong base for the asphalt. The compacted volume was calculated as 770 meters cubed. However, when transporting this material to site by transport trucks, a loose density would need to be obtained, and this density was 983 meters cubed. Using a similar operation of finding the cycle time needed for the delivery of the limestone crush, we were able to find all associated material costs and delivery costs, roughly equaling $22,000 for the limestone.
The water main installation will be completed by subcontractor Condrain. However, we will supply all required materials. Condrain will be responsible for all labor and equipment required to complete the water main installation. The water main will run from Gate A to the hydrant located at the end of the cul-de-sac. This process will begin with the excavation of a trench 1.2 meters wide at the base and 2.6 meters in depth. Next, the 150mm water main pipe will be laid with crusher run limestone as bedding and covered to protect it and prevent it from pipe damage. The trench will be backfilled and compacted to ensure adequate coverage and protection. Backfill will be to the elevation of subgrade for asphalt and concrete crews to take over. As you can see, Table 4 shows all the materials that we will supply to Condrain to complete the installation of the water main. Table 5 shows the excavation and backfill quantities. Overall, we are committed to demonstrating excellent performance in both construction and safety for this project. We have dedicated a significant amount of time and resources into estimating the cost and appropriate methodology to provide the most accurate information. Thank you for taking your time to review our proposal and bid of $1.24 million. We are looking forward to hearing from you soon.